Intel Core i3. The Intel Core i3 serves as the foundation of the modern computing experience. It's the processor you select when you need a machine for everyday digital life without any unnecessary frills. Imagine a student typing up essays, a family member checking email and scrolling through social media, or someone streaming their favorite shows in the evening. The Core i3 handles these tasks with comfortable ease. Typically equipped with 4 to 6 physical cores, it provides enough parallelism to keep your system responsive while you have a few applications open simultaneously, like a web browser with several tabs, a music streaming app, and a word processor. While it's not designed to be a powerhouse, the Core i3 can still surprise you. It can manage lighter, older, or less graphically demanding games, such as indie titles or classics from a decade ago. However, its limitations become apparent when you push it harder. Attempting to edit high-resolution video timelines or rendering complex 3D models will result in noticeable slowdowns. This is the trade-off for its affordability. It's the perfect engine for a budget-conscious build where the primary goal is functionality and reliability. The letters you see attached to the model number are crucial for understanding its specific role. In laptops, you'll frequently encounter the U suffix. This stands for ultra-low power, meaning the processor is engineered to conserve energy. This results in a cooler-running laptop that can last through a full day of classes or meetings on a single charge. On the desktop side, you might see an F at the end. An i3-12100F, for example, lacks integrated graphics. This requires you to use a separate graphics card, but it also makes the chip more affordable, an excellent strategy if you're building a budget gaming PC with a dedicated GPU you already own. There's also the T variant, a highly power-efficient version designed for small form-factor desktops or home theater PCs where minimal heat and noise are paramount. Intel Core i5. Stepping up to the Core i5 places you in the sweet spot of the processor market, the zone where price meets performance in a way that satisfies the vast majority of users. This is the chip for the creative hobbyist, the dedicated gamer, and the multitasking professional. Core i5s boast a wider range of core counts from 6 in older models to 14 in the latest generations, often utilizing a hybrid architecture of performance cores and efficient cores to intelligently manage workloads. This architecture allows an i5 to handle demanding tasks like compiling code, editing photos in Photoshop, or cutting together 1080p video projects without breaking a sweat. In gaming, it's widely considered the gold standard, delivering high frame rates in the latest titles without the premium cost of a top-tier chip. A common misconception is that the tier number is the only factor in performance. A newer generation i3 can easily outperform an older generation i5 due to architectural improvements and higher clock speeds, showcasing the rapid pace of technological advancement. The suffix system expands here. On laptops, alongside the U version, you'll find the H series, which indicates high-performance silicon. These chips consume more power to deliver much greater processing muscle, making them the heart of many portable gaming rigs and mobile workstations. On the desktop, you'll find the K suffix appearing on some i5 models. This designates an unlocked multiplier, allowing users to overclock the CPU. By increasing the clock speed beyond the factory settings, you can extract extra performance, though this requires a robust cooling solution, such as a high-end air cooler or a liquid cooling loop to manage the additional heat generated.
The Intel Core i7. The Intel Core i7 is where we enter the domain of high-end performance, tailored for users who demand more from their machines. It's the processor for the content creator who streams their gameplay, the engineer running complex simulations, or the data analyst working with massive spreadsheets and databases. With core counts ranging from 8 to 20, i7s provide the necessary headroom to not only run a primary heavy application, but also to keep all the background tasks like communication apps, system monitoring tools, and dozens of browser tabs running seamlessly. This level of power transforms a workflow. With the Core i5, you might need to close other programs before rendering a video. With the Core i7, you can keep editing while the render happens in the background, or you can game at maximum settings on one monitor while streaming the gameplay to an audience on another. The multitasking capability is its defining characteristic. In the mobile space, the i7 pushes performance even further with suffixes like HX. These processors are the most powerful available for laptops, often found in thick, high-end gaming laptops designed with advanced thermal solutions to dissipate the significant heat they produce.
On the desktop, you'll find the FK variant. This combines the unlocked K overclocking capability with the disabled integrated graphics of the F series, offering a slightly more affordable entry point for overclockers who will be using a discrete graphics card anyway. It's worth noting that in the high-end tier, competition from AMD's Ryzen 7 series is fierce, often providing comparable or better multi-threaded performance and better thermal efficiency for a similar price. Intel Core i9. At the apex of Intel's consumer lineup sits the Core i9, a processor that represents the absolute pinnacle of desktop performance for enthusiasts and professionals. This is raw, unbridled power. With core counts soaring from 16 to 24 and beyond, the Core i9 is designed for workloads that would cripple lesser chips. We're talking about studio-level 3D rendering, compiling massive software projects, performing scientific calculations, and editing multiple streams of 8K video. For gaming, a Core i9 is overkill for most titles, but it provides an unparalleled level of future-proofing and the ability to maintain maximum frame rates even when running background tasks. It ensures that the CPU is never the bottleneck in a system. The suffix system mirrors those of the i7, with K, KF, and F variants being common, all offering the same overclocking or integrated graphics options. However, the conversation around the top tier has shifted. While the Core i9 is undeniably powerful, many gamers and professionals are now looking at AMD Ryzen 9, particularly the X3D variants. AMD's 3D cache technology stacks additional cache memory onto the processor die, which can provide a massive performance boost in games by allowing the CPU to access frequently used data much faster, often without a significant increase in power consumption. This makes the choice at the flagship level more nuanced than ever before. Intel Core Ultra. The Intel Core Ultra series marks a significant evolution in processor design, moving beyond the traditional Core i naming scheme. You'll primarily find these chips in premium modern laptops for manufacturers like Asus, Dell, and Lenovo. What truly sets Core Ultra apart is its fundamental architecture. It's not just a CPU, it's a system on a chip that integrates a dedicated neural processing unit, or NPU. The NPU is a specialized engine designed to accelerate artificial intelligence tasks locally on your device. Instead of burdening the CPU or GPU with these processes, the NPU handles them with remarkable efficiency. In practice, this means your laptop can run AI-powered features without getting hot or draining the battery. For instance, during a video call, the NPU can power Windows Studio effects to automatically frame you, maintain eye contact, and blur your background. In creative applications like Adobe Photoshop or DaVinci Resolve, it accelerates AI-driven features like object selection, auto-reframe, and generative fill. While these AI capabilities are impressive, the Core Ultra also delivers strong general performance and excellent power efficiency, making it ideal for professionals on the go. The inclusion of the NPU is a forward-looking step, preparing our computers for an era where AI becomes an integral part of everyday computing tasks. Intel vPro. Intel vPro is not a specific processor model, but rather a platform technology found on select versions of Core i5, i7, and i9 processors. It's designed from the ground up for the business and enterprise environment. When you see a vPro sticker on a laptop, it signifies a device built for security, manageability, and stability in a corporate IT setting. The core of vPro is Intel's Active Management Technology, or AMT. This allows IT administrators to manage fleets of computers remotely, even if they are powered off or have a corrupted operating system. They can push updates, diagnose issues, or lock a device from a central location, saving countless hours of hands-on support. Complementing this is hardware-based security like total memory encryption. This feature automatically encrypts the contents of the system memory, protecting sensitive information like login credentials and encryption keys. If a laptop is lost or stolen, any attempt to physically extract data from the RAM will result in scrambled, useless information, adding a critical layer of data protection. Intel Atom. The Intel Atom family is a testament to the principle that a processor doesn't need to be powerful to be incredibly important. Atom is an ultra-low-power architecture, engineered for situations where electricity consumption and heat generation are the absolute top priorities. You won't find Atoms in performance laptops or desktops. Instead, they power the technology that quietly surrounds us. Their primary application is in embedded systems. Think of the point-of-sale terminal you use at a coffee shop, the digital information kiosk at an airport, or the smart display on a home appliance. These devices require a processor that can run a specific application reliably 24/7 while generating so little heat that they can be cooled passively without a fan. This allows for completely silent, durable, and energy-efficient devices. Atom processors are the silent workhorses of the Internet of Things, powering everything from industrial controllers to network-attached storage devices. Intel Celeron and Pentium. The stories of Intel Celeron and Pentium are deeply intertwined, representing the company's historical approach to the budget and entry-level market. Both were eventually discontinued as a separate brand in 2023, their roles largely absorbed by the low end of the Core i3 lineup and newer, more efficient Atom-based processors. Celeron was positioned as the entry-level option. Its origins lie in Intel's practice of taking higher-end processor chips that had minor manufacturing defects. Instead of discarding them, Intel would disable the faulty cores or cache, creating a chip that was fully functional but had reduced capabilities. This allowed them to sell a processor at a very low price. A Celeron could handle the most basic of tasks like a single word processor or one web browser tab, but its limitations became immediately apparent under any heavier load. Pentium sat just above Celeron. It offered a bit more performance, perhaps a higher clock speed or more cache, for a slightly higher price. This made it capable of smoother basic multitasking and could even run older, less demanding games. For many years, the Pentium was the go-to brand for budget home PCs and office computers. Both brands, however, became synonymous with the lowest tier of performance, and their discontinuation marked the end of an era in Intel's branding history. Intel Xeon. The Intel Xeon processor is built for a different class of computing. It is not designed for a standard desktop PC, but for the heart of the digital world: servers, data centers, and high-end professional workstations. Xeon processors are engineered for relentless 24/7 reliability and massive parallel processing power. To achieve this, Xeons pack an immense number of cores, ranging from 32 to 56 in common models and scaling to over 120 cores in specialized variants. They also support advanced features like ECC, or error-correcting code memory, which can detect and fix data corruption, ensuring the integrity of critical calculations. Perhaps their most defining feature is support for multi-socket motherboards. A single server can be built with 2, 4, or even 8 physical Xeon processors working in tandem, pooling their cores to create a computing monster capable of handling cloud computing, large-scale scientific simulations, and massive database transactions. For years, Xeon was the undisputed king of this realm, though it now faces strong competition from AMD's EPYC and Threadripper processors, which have challenged its dominance by offering compelling core counts and performance per dollar.